for coming into the beach, whatever. My name is Jonathan Gohstand, and this is Nigel Daniels. And what we'll do is we'll spend the next hour or so, we'll try to get you out a few minutes early so you can make the transition to the next one, of covering the problems of legacy Java and also kind of the approach that Warwick actually developed to try to deal with this and a few other problems as well. So, get the clicker, that would help along. So we'll talk a little bit about setting the stage for where this technology fits in. Our secure Java containers, which are the core technology, and then the Java legacy Java use case is in the abstract, and also how you can use this for SQL injection. We're all going to do some demos, so what I'm going to try to do is jam through the slides reasonably quickly so we've got more time for Nigel to do the demo of the actual product and work and mitigating attack and all of that, so it's a little more interesting than PowerPoint, which you guys get plenty of, I'm sure. So we all know that application security is kind of underfunded relative to its value. I've done a lot of security for years, and I was just listening to a talk by some big CISO for some giant insurance company I won't name 2 days ago, and he was talking about his budget, which was like $150 million, and then he was saying, but you know, a lot of that is chewed up because we're upgrading our Palo Alto firewalls this year, right? Like to the tune of tens of millions of dollars or some stupid thing. So whenever I talk to security guys, there's still much more than like, let me just play my network sandbox stuff and that application stuff I try to stay out of. So that leaves us kind of holding the bag up at the application level where frankly the security could be applied much more effectively given the money. That was interesting, the keynote, saying she only spent 28 grand for those bugs hitting an IE. All these recent attacks in press aren't going to change that overnight. There's always the latest attack that every security person thinks suddenly the money's going to start flooding in for their particular approach. It never happens. It keeps the boil going, but it's not like suddenly things change continuously. So we need to look for things that maybe will approach the problem a little more differently and maybe allow us to scale up application security a little easier than what we're trying to do now, because it obviously isn't like totally getting the job done. Nothing is. So if you look at kind of where we could put security, it's kind of like low to high. You got all this money being spent down at the bottom with firewalls and antivirus and junk like that. Lots of money spent doesn't really solve the problem. We all know that. It's amazing to hear these, like the same insurance guy who spent all that money on Palo Alto, like 2 minutes later says, well, another big thing around here is the perimeter is dead. Like, okay, the thing you just spent a ton of money on, you just said is worthless. It's like, I didn't even have to propose it to you, you actually told me. It's crazy, but he's got the big title. So the next thing is you can do things up in the operating system. This typically is agent-based. It's really more of a placement thing. They usually don't have super good connections into the application. Obviously, they can have some ties into the OS. The placement is nice, though, obviously, because then you're much closer to the application. It's harder to go around it. Application security, obviously, that's why we're all here. I won't spend a lot of time there. You can do anything if you get up into the app. The problem is doing it at any scale, especially if you talk about, a bank or insurance company or something like that. It's one thing to talk about it. It's another thing to implement it. But that leaves the runtime, the piece in the middle there that's kind of open, and that's where we play. There's this idea of inserting security into the underlying platform. In this case, what we're working on is the Java JIT compiler, or the Java virtual machine layer. So above the operating system, but below the application. So this guy, Joseph at Gardner, he's on this like one-man band trying to form this RASP category. There are a few companies participating. We're here, you see Previty is here. I just met a buddy of mine I hadn't seen for a few years. He's at Shape Security. He was like, oh yeah, we're playing in RASP. And I'm like, oh, I didn't know that. So you can go check out what they're doing. There's maybe half a dozen companies trying to build security directly in at the virtual machine layer, and Joseph Feynman is a big proponent, which is definitely useful if you're trying to justify any of this stuff. You say, well, Workers says it's okay. So next thing you know, people are actually paying attention. So, and he's a cool guy. So let's talk about the technology itself and what we've developed. If you look at the typical stack, you've got the operating system at the bottom, in this case, the Java virtual machine, and then you've got all this stuff above. Now note there's all kinds of things between the actual business logic and the virtual machine. Obviously there's the Java APIs, there's the frameworks, and there's a lot of third-party libraries and open source code. You'll find the quote there that Nigel pulled was, 20% of the code might be homebrewed, the rest of it is all pulled in from somewhere else. So there's a lot open source third-party stuff in there as well. So there's a whole pile of things where the vulnerabilities can be found. And that stack generally is also insecure because up at the application layer, the only security inherent in Java is the security manager. And the security manager can easily be attacked because if you inject code up there at the Java layer, you're basically at the exact same layer as the security manager. The security manager is not running down in a more privileged rig. It's right up there. So the first thing the malignant code will try to do is kick out the security manager and shut it down. So the core Java security model is just really, really limited. It doesn't really let you do too much at all very, very reliably. If the SM is compromised, then you can basically do anything. So basically, it's a bad situation. So, okay, so what have we done about it? We've created the idea of basically virtualization or containerization at the Java level. So instead of having your JVM, you drop your application in JVM, now you have a container within which you're running your Java applications. And in fact, you can run multiple Java applications underneath that single Waratech JVM. We basically took the Oracle Hotspot JVM, made heavy modifications for security and virtualization to that, and that's basically what you're getting. So in this case, we showed 3 of them, it doesn't matter. Now, each one of those containers can boot their own runtime. They can even be different versions because you've got this abstraction layer, which is our virtual machine running underneath. So the idea is here to take a look at this. Now what you've got is your Waratech JVM presenting the runtime up to the application at whatever level you want. And in a high level, there's basically 2 big things that we're bringing to the table. One is the core containerization or virtualization, where you've got this now sort of bathtub now sitting around the application, providing isolation. And then the second thing is there's a whole number of security features we bring into that bathtub that you can use to do very specific things. And that's what we're going to talk about for the rest of the thing. You can do things like a profile what the application is doing, and then set up rules specifically based on what it normally does, so you avoid it trying to do anything else. We'll talk about the taint detection agents later. Should also point out that it also includes coverage for the Java data interface. So the JNI is a way we can basically jump out of the Java environment and make operating system calls, typically for performance reasons. We also protect that interface as well, which is very, very unique. Obviously, if you're operating only higher up, you can't do anything like that at all. Now, the rules engine that's built into this container do all sorts of things, and I won't spend a ton of time on all the details here. But it's everything from which classes can be loaded, how to handle throwable exceptions, what files you can write to, network stuff, whether you can process for. If an app doesn't process for, then you sure as heck shouldn't let it process for. If it does, then something's wrong. And we'll give you an example of SQL injection and how we can do things with SQL injection later. But the idea is basically this container is isolating and then watching all the activities of the application and is in a position to alert or block based on what it's doing. The nice thing about the rules is A, they're simple, and B, you don't have to take the system down in order to instantiate new rules. So if you find something that you want to mitigate quickly, you can insert a rule. You don't have to restart the app or the JVM. And unlike, say, a WAF or any kind of signature-based thing, the rules tend to be very, very simple. Like, we'll show the SQL injection stuff later when Nigel does his demo. It's one line to turn that engine on. It's not a bunch of string matching or anything like that. And you can see some of the other examples, very simple stuff based on, in this case, file paths, an example, or network. So let's turn to legacy Java, and then Nigel will do the first demo. So as you guys probably know, there's all kinds of old Java slopping around in organizations. This one's a couple years old. Obviously now version 8 is out now, and 7 is going to be end of life. What is it, April? It's going to be April 1st, April Fool's Day. So there's all of this old stuff floating around with all kinds of old vulnerabilities, and of course nobody wants to update because they don't want to take the responsibility for updating the app or all the old code that's lying around that's dependent on that old Java. That's why it sits out there. This is some of the stats, 93 orgs are running Java over 5 years old, 51 conversions of Java, blah, blah, blah. And of course, there's all these CVEs against these old ones. In this case, that example is Java 6, right? So basically, it's a major pain. It even gets down to objects. Nigel was talking to me about this yesterday, where you can have objects basically that are stored and they're dependent on particular versions of Java. So if you upgrade the Java version, you can't just use that same object. You just have to pull all that stuff out, make sure it's all translated to the new stuff, and then it'll put it all back. So it's a huge upgrade process for this massive database that nobody wants to take responsibility for. So it's basically an issue. So what are we going to do about it? Well, if you put 2 and 2 together, you figure out that what we do simply is we allow you to continue to use the old version of Java inside the container while we provide the modern version of Java underneath, right? So we're containing the old version inside the new version. So of course, the most important thing there is the application is seeing its original version of Java. So as far as he's concerned, there's no change at all. As I mentioned before, it's because you can virtualize this, you can even run different versions on one JVM. That's what Nigel's going to demonstrate. So basically, the top part is obvious because I haven't changed the version of the app seeing. There's no changes, so all 4 of those things are obvious. And then I can really get to kind of the problem. A lot of times the problem is around compliance. There's some auditor who says like, well, this stuff's old and I read this all these vulnerabilities, and there's a process that says we have to be patching and you're clearly behind and what are you going to do about it, and blah, blah, blah. And it's like you can get the guys off your back with this compensating control, which says the application is unchanged, but I'm running underneath a modern JVM, and the modern JVM is what's protecting me from the outside, and therefore I basically get lost. That's basically the idea for legacy Java. So it's actually a very simple idea, and that's what is attractive about it, is it's a simple way to protect legacy Java apps without having to touch the app, and that's what everybody's trying to do. And with that, we'll get to the first demonstration, and I'll turn it over to Nigel.
Okay, so he gets to talk and do the slides and we get to do the dangerous bit.
Yeah,
so
right.
Demonstration.
I'll just stand far away.
Thanks. Okay, let's jump over here. So, we're running a Mac here with our systems running up on a Linux platform. So I've got a virtual machine running here, running CentOS, and that's got our JVM installed. And all I'm going to do is kick up the startup script, which is going to fire up 2 instances of Tomcat. I've got Tomcat 6 and Tomcat 7 running. We're going to fire both of those up. So it's fairly straightforward. Focus on here.
Pressure's on that. We were going through this yesterday, and he was like doing save password for all the stuff I can say later, so he wouldn't.
Yeah.
It's really working.
Software is always so much fun. Okay, so there we go. We've not much to see, not very exciting really, but we fired up 2 instances of Tomcat here. Tomcat 6 is kicked up, and the interesting part is this JRE code. So what we've done is we've set the environment variables for Tomcat and said, when you start, you're going to require Java 5, Java 5. So it's made that request, it followed its regular startup scripts, we've made no code changes, any alterations. The only alterations to the environment settings say, you need Java 5. Straight after that, we fired up Tomcat 7, and here it's JRE home it's asking for is 6. So again, it's kicked up, it's started in a container, and it's now running on what it used to be a Java 6 platform. In fact, the JVM underneath is Java 7 JVM. So both of these are running now in legacy containers. So all things being equal, let's go just check that out. Okay, so this one has 6. We're connected in on local host, it's running 6060. And I'll just check the manager. So it's running various things, and here it is. It says I'm running on Java 5 on Linux. What's good in the world? So just moving over to Java 7. So this one gives us the same presentation. We've got a few more things running on here. So we're running web Go We'll be looking at those a bit later on. But here we go, it's now reporting the unlimited JavaScript JVM. So both of these are upcoming and sort of fairly happy with where they are, both legacy applications. So if you've got third-party apps demanding a back-level version, you don't have the code to change it and upgrade it. You can just pop in one of these boxes and it's happy.
Easy. So that was the easy one.
Nice and simple.
Thank you. Okay, easy one. So let's talk about something more complicated, which is I gotta turn this on. Which is SQL injection. So how many people are well versed in SQL injection? So we all get it, right? So SQL injection is, we're on the input side of an application. You shove some stuff in that somehow makes its way into the back-end query to the database, and the result you're able to extract data as opposed to just a single record or whatever it was you were supposed to get. I used to do network-based security stuff years ago, and I used to always get this from companies who were concerned about this problem because they just didn't have it licked at all. They had applications they had no control over. They said, well, because we were looking at it on the network side, they'd say, well, you got this app sitting here and you guys can tell me what the clients are doing on the front end, but then can you correlate that with the queries that are going out the back end towards the database? And basically, no. And by the way, nobody else could do it either. There was just no way from looking at the outside to match up what was going in from the front, which was what was going out in the back. And that problem persists. As you can see, any type of injection attack is still, OWASP top 10, that's a 13 as of the last one. Still a problem. There's all kinds of variant SQL injections, obviously, probably the best known. So basically what we've done about this is because we've got this layer now sitting there in the virtual machine piece of the stack, we've created what we call this taint detection engine. So basically what we're able to do is we're able to model abstractly what the thing going out the back is supposed to look like based on, in this case, the syntax of a particular SQL variant. We started with Oracle. And what we can do is we can basically track the input side, know which pieces of it are tainted, that is, which ones potentially were affected from the user input and which weren't, and then watch to see if it changes the syntax, right? So the idea is like, I know which ones could be my problem, I know what the structure is supposed to look like of the query. If the bad stuff changes that syntax on the back end, then something's wrong. And because where we sit in the JVM layer, if we detect a problem, it's not like a WAF where we're just going to kill a session or something like that and hope the application somehow recovers. We can do a throwable exception, so it can be caught by the application developer, and the application can deal with the effect gracefully. So, big advantage of this, of course, is we're not asking for any sort of tuning or regex or anything like that. It's just going to basically go out of the box with a one-line rule. Here is the one-line rule. We took a look at it before. Where basically you just say, turn this engine on for, in this case, Oracle SQL queries. And then what you want to do, when it happens, if you want to actually kill it or you just want to warn on it. And that brings us to the more complicated demo. How are you feeling, Nigel?
Oh, ready for this one.
He's ready.
Okay. So we thought for this one, we're going to go well understood around here, so we'll use that or not. So let's bring it up. Just the automated terminals to the streets. Do you want to use? So let's bring this in and we'll. There you go. So we figure what we'll do is just a fairly straightforward, simple numerical injection that's nice and easy. We can see fundamentally what's going on underneath, and then I'll go into a bit more depth of how we're doing what we're doing, and we'll look at why it's different from other approaches. So here we go. Very simple query. We just fire off the station number, saying we want to know what the weather is in Colombia here, and sending this identity, and we're getting back one line of data. So if there were a man-in-the-middle attack going on, it would be something like using maps. Call that up. So yeah, got that there. So we start intercepting that request, we can start seeing what's going on, get an opportunity to start injecting stuff that shouldn't be there. Someone else, and we want to Seattle. Okay, so that's not going to come back, so it's now sat somewhere in here. So here's my request, which you can see on my mouse pointer. So if we take a look at the parameters, here's the station ID. So straightforward. This one's no thing. Let's forward that on. And let's use those options. Results into all sorts of other stuff. I'm tapping it already. That's great. It's familiar. So you get to watch me fell wood go Gohstand, that's great.
Turn on all cameras. It worked last night, remember that?
There we go, that's one.
Are you trying to do an injection? Injection?
Yeah.
So, I'm going to do a single quote on 101 or 1 equals 1 and then a space.
Normally this doesn't require quotes.
So it doesn't.
There we go. Software demos. Okay, so we found we can now return the whole database by injecting some SQL, which is just clearly not ideal, so we need to stop this from happening. So let's reset this lesson. Okay, so we back up. And still in the so what we've got here is we've set up a set of rules. The rules file we can look at. And what we're doing currently is just logging what's going on when we're doing any deny. So I'll switch this rule into play. And take this one out because we don't need to.
So everybody can see that deny on that red rule.
Yes, so it's kind of like just clicking on switch. And I've got a script just to put that in the correct place. It's saving down. It's like just a screen. So what that's done is it's copied that rules file into the containers location, so the container's got a file structure representing what's going on inside each of them, just recording out from memory they're using, whether that's where the security logs will live as well. We've copied that in place and then filed a request to reload the rules. And we're still running web go. We've not done take a break or stop or shut down to reload these things. We can update lines. So if I try do this one again, and hopefully not that finger at work first. Switch to set on. Here. Okay, so one. Let's forward that file. So okay, this time this is the result we get back. Since it's to execute query one or more parameters. So what's happened is internally, our take protection engine has picked up that this injection is taking place, and because we're living inside the Java execution layer, we can throw back an exception. Now, in Java language, programmers are forced to deal with exceptions. They're an error mechanism, which means that if you're in the middle of a transaction or something like that, and an exception gets thrown, you have the opportunity to roll things back gracefully, or in this case, display something on the screen rather than just bomb out in the middle of the fail. So we take advantage of the location of the settings. So okay, well, we'll look at how we're doing this and go into the team protection in a bit more detail. So, as far as the Java virtual machine is concerned internally, it's representing an SQL statement as a syntax tree. So if people are familiar with syntax trees at all, does anybody have to deal with those? It's basically a way of structuring a language in a tree like this, so we understand it's a query. The query is always made up with select, from, and where. It then has these other things underneath which can be identified as the username and the kind of information. And we can see that at the end, this is the brand part, this is what the user is going to be inserting, and this is where our vulnerability sits. So when we're injecting the OR and injecting the one, this is the kind of thing we're getting. We're actually changing the structure of this thing. We've now got this sort of thing appended at the end. It's perfectly legal as far as SQL is concerned. That's our helpful. And that's why it's executing it happily and returning a whole pile of data that shouldn't be returned. But how do we normally try and detect this or prevent this? Well, prepared statements deal with it by basically saying, well, we're forcing this structure to be this structure. Anything that appears down here, this is the bit we've said in our prepared statements, is the bit people can add into. We'll just treat that as a block. We find any SQL statements in there, we don't decompose them any further. We just kind of force the structure, which is fine. Although some things want to be more dynamic, you may want to construct your queries on the fly, depending on what the user's trying to do and the interaction they're trying to have. So, what happens with many other systems is they're trying to do some sort of pattern matching to say, well, given the query I'm being presented with, can I spot a pattern in it that's showing me the structure's been changed? But it becomes kind of difficult because it's still legal syntax, and if you don't have the contextual information as to where all this information came from, then it becomes very, very difficult to see what's legitimate and what isn't. This is why a lot of false positives get driven, especially around SQL injection. It's because people are having a really hard time differentiating between what's legitimate and what isn't. So, what we do with tape tracking is we're sitting underneath the application, we're sitting in the execution layer. Anything coming into the application passes through us. Anything happening inside the application we see, and anything passing outside the application. So we're in this privileged position of being able to say with certainty where everything came from. So in this case, we know with certainty that this was added by the user. All the rest of this could be from static strings inside the application itself, read out the file, we'd spot that as well, we'd know where it came from. So we could say, what level of risk does that present? So if we see that, hey, our syntax tree has changed, there's a new structure, and that new structure came from external to the application. It came from a web request, or it came from a user entry field in a larger desktop application. We know that for certain. So now that we've got all this contextual information, we can start saying, well, is this an attack or is this legitimate behavior? So we see that there's a space by the name, we see that there's syntax in there, we see that there's a change to the tree, that changes, or stuff that came from the outside world. We now flag that with near 100% certainty that this is an attack going on. I think it's very Kiri is convinced of what we're doing, and tried to do some false positive testing and said we wouldn't need to trigger any, said it's the nearest it seems to zero false positives so far. So we're quite happy that this seems to be working pretty well. And the next step for us now is to start looking beyond SQL and start looking at problems in cross-site scripting, because it's a similar issue. It's knowing where information came from, being able to track where it came from, and understand is it legitimate or not. Do you want to go straight into the next step?
Yeah, just 2 more slides on the Yeah, one. We have plenty of time. Do you want to do another demonstration?
Yeah, let's it's almost myself saying volunteering for another demo. But so what we've set up on here is JForum. This link where I've got JForum direct. I'm not using it, but I'm setting something again. No. So it's a kind of bulletin messaging board. I'm going directly to it here, regardless of the injection rule on. And it lets you post stuff. So I can do a new post. I think. So we can post this. Okay. So basically we go to the board and to learn more about various products, for example. So that. So our post has gone up. That's fine, it's all working as well. What we've also got running on the CentOS box is we've set up the AppSec library. It's an add-on to Apache which does sort of WAF. It's trying to detect anything bad stuff. It's a kind of WAF that's using pattern matching. So by connecting from there, going through that AppSec, is that okay? Let's reply to this. And we just say you can those products we set from that. Boom. I'm on box, so what was going on, why can't I post on this kind of AppSec is doing some pattern matching. So so if we have a look at, let's do a little bit for this. Okay, so AppSec, so it's all a block. If we jump into the bottom of this thing, so somewhere up here we go. What it's done is it's seeing where I've said select from, and it's pattern matched on that. And it's then saying, hey, there's an SQL select statement buried in that message. There's an SQL attack going on. Well, no, there isn't. I was legitimately posting this like it, saying, I'd like to select some product. But AppSec's done its best and it's matched something and said, hey, I'm going to block this. So we're just using the actual box. I don't think people normally use this out of the box on the bulletin board. But if they did want to use it, it just shows they have quite a level of tuning that you have to go through and testing before you can deploy this in a production environment. But if I go direct, I can say, let's go back here. So I can point here and say, this is going direct by RC Milsec. Got the forbidden set of form in there. But we're not paying attention to that. So before it's just stopping the SQL types from the text, it's changing the syntax tree. There's no syntax tree here. So that's fine, it's just okay. So we're all through the demos.
Very good. Okay, just a couple more slides and then we'll take any questions. Great. So the way we've set up the solutions that you can deploy in a few phases, the first one is the profiling phase. So what you can do is, when you're down developing the application, getting into test phase, you can go ahead and run it on our virtual machine. And basically what will happen is it'll generate a real-time report of absolutely everything the application is doing. Now this will be a gigantic file that will run into gigabytes of data. But then we've got this plugin that analyzes that that data set, and what it does is it boils it all down in just a couple of pages of the specific rules that model what the application actually does, right? And again, it's that same list of stuff from processes and classes to network and file, any kind of I/O, et cetera, et cetera. And that profile alone, of course, is very, very useful because now you immediately have this very, very detailed view of exactly what the application is doing. That can be useful for security. It can also be useful just for providing information back to the application developers. Now, I guess Nigel was talking about, actually you should just tell the story about the skins file. Remember the skins directory? That's a good example.
Yeah, we've started working with some customers with this, and one team in constructing their own enterprise application. We're running this against what they're doing, and the security team said, well, look, okay, guys, take a look at this. Is this describing the behavior of your application? It's the dev team. We just wondered why you're reading the skins directory every 10 seconds because it doesn't exist. And the team were like, well, we're not. What do you want about? We never wrote that code. What it turned out to be is they used some components, some open source components to construct the UI. These had this behavior of looking for this skins directory, which told them how to reconfigure the UI. So if you constructed that directory, you put the appropriate config files in, you can start changing the behavior of the application. And they had no idea this was going on. They just used this component out the box, plugged it in, used the bits they needed. And suddenly you realize they'd included all this other behavior that was just, who knew that was there? Well, they did after they saw the rules, but...
Yeah, so then it kind of speaks to that third party problem. If 7 or 8% of your code is third party, there's no way the application guys are spending much time worrying about it. If it's getting the job done for them, they're just moving on and worrying about completing the project. And so that's where this profile can be very useful with feedback, the feedback from those guys, and actually getting them to see some value of working with you guys, frankly. Then the second thing you can go is then you can start saying, well, let me try to put this in production, but just alert on if anything funny happens, right? So you would basically say, well, I'm going to move into production phase. I'm now going to use this rule set that's been generated for me because I profiled the app before. I'm going to run it on the WireCheck JVM, but if it finds an exception to the normal behavior, I'm not going to shut everything down. I don't trust anything that much. I just am going to log that and then go back and take a look. So I'm going to kind of run it in alert-only mode, if you will. I can feed it into my SIM if I want, however I want to deal with it. The point is I'm running in the isolated container and I'm just looking for exceptions to that behavior. And maybe there's something I didn't check because I didn't run it long enough before, there's a monthly close or whatever. You basically run it in this mode as long as you want. And then you can leave it there forever if you have a process in place that says, well, if I see an exception, I actually go take a look at it and do something serious about it rather than letting it sit in some log somewhere piling up like Target did, right? And then, of course, hopefully once you've got the confidence level where you need it to be, you want to put it into the active defense mode where, in this case, if there's an exception to the rule or the detection engine is put into blocking mode, then you're gonna go ahead and actually gonna stop the behavior that deviates from the standard. You're obviously still gonna log it, you're gonna let people know what's going on, but you're actually now gonna shut that behavior down and stop the problem right where it starts. So hopefully you'll get to that stage. There's Nirvana. And just one last slide. Do you want to maybe take this slide? You know this material better than me.
Sure. I've seen how people tend to behave, or how most people work in the car application when they use it. The question is, this is great in POC, great in a single machine, but we've got like 10,000 servers out there we need to deal with. How do we handle this stuff at scale? So, in fact, the environment I've got on here, we put together, I put it down using Puppet and Chef and all of these configuration management tools. We've got quite a library of different modules for all of these now. So what we're doing is providing those as templates to people. So you can very quickly say, I've got 500 machines over here running application A, I need to push out a rules update or a change to more, then we can kick off and script it and it can be managed. We've got a set of APIs as well for the management and control of this system that can be turned on or off. The default is actually JMX, which is Java's native way of managing a JVM. We've built some APIs on top of that using SSH, so you can actually log into the JVM and start controlling it if you wish, or using a REST API for those who want to build UIs, but those two are kind of switched off as default. And they don't present a risk on themselves.
Thanks. So that's it to summarize. Basically, we think the runtime layer is really underutilized with a powerful place to insert security. Gartner and Feynman over there is logged onto this RAFs category, so I'd encourage you to take a look at all the solutions that are operating in that space and see where they might fit for you guys. We've developed our application security for Java, which gives you this isolation, the ability to do threat forensics against your apps, and then alert or block on exceptions to those rules, or using the taint detection engine, just using things that break the syntax, so in this case, SQL and then other types of attacks coming out later this year. And of course, the big thing is no app changes. And it's also portable, right? Because you're running the JVM layer, if you've got infrastructure as a service on your roadmap, no problem moving this up when you move into an IaaS model as well. And so that's it. We'll hang around and take any questions. We also have we have like screen wipes. If you want nice screen wipes. I know these are good screen wipes because the guy at the table next to us downstairs, he goes like, oh, I borrowed one of these before you guys showed up. Do you mind? This is the cleanest my screen's ever been. So if the other vendors say it's good, it's got to be good, right? So any questions? And we'll hang around, like I said. Yes, sir.
You can put them into the Go environments as well.
I'm sorry?
You can also support other environments such as Go or other languages.
Yeah, so I guess the Windows environment would be the main one. In terms of languages, I don't think it really matters.
No, we do support other languages that are on JVM, so being able to write Groovy, Python, JRuby. Ones we support in terms of the security rules are mostly Java. Some of the rules will apply to other languages, but the rules are mostly looking at the Java API. But you can certainly run other languages on the JVMs.
Any questions? Joe? Okay, good. Thanks for hanging around. Oh, that's the thing. We know when the application is pulling input from the outside, and we're able to mark that. What we call is marked as tainted. This thing actually called taint tracking in Java, right? It's similar to that. So now we know which components of the query or potentially from the outside.
parentheses, does that change the syntax of the query? Right, so you know, if the internal code changes the syntax, if the input side, that side changes. If you want to go to any yeah, we'll be okay. Thank you.
Yeah, so let's see who's just, we should try to catch them. Let's get him. He's about to speak, so maybe I'll just sit. Do you want to sit down and do it? No, I don't really want to. Yes, that's right. I know, it is right, yeah. Let me take that for you, you go to your business. I'll take one back.
This way,
Okay. I forget it, when I lived in Moscow, my SC was massive. And so, you know, all our meetings and schedules all, you know, rotated around signal. So it's like, okay, let's get it. He was very good at like quickly the 70 at the door and light it. And then we have to walk to go find the car. And tough that he'd go through that thing so fast.